Welcome back, Math 136 students, to the Module 06B Problem of the Week. So in this problem, you're being asked to identify or find the domain of the function, and this is a logarithmic function. So the first thing you need to understand is that you are not permitted to evaluate the logarithm of a negative number or even zero. So for that reason, what we're going to do is take whatever expression that is inside the parentheses that you're evaluating the log for, and you are going to set that expression, which is x plus 2 over x minus 1, and you're going to set that greater than 0. Now, the challenge then becomes is you now have a rational inequality, so you're being asked to solve a rational inequality, and the solution to that rational inequality is then going to be the domain of this function. Notice that at no time did the base of 3 ever play a role in this. So it all has to do with what's inside the parentheses. You set it greater than 0 and you solve the inequality. So let's start by identifying the two main attributes of the rational inequality that we need to find in order to solve this rational inequality. The first attribute is going to be the x-intercept. The x-intercept, you set the numerator x plus 2 equal to 0. You solve it, you get as x equals negative 2. So the x-intercept is negative 2 comma 0. The second attribute is going to be the vertical asymptote. You set the denominator x minus 1 equal to 0. You solve that, you get x equals 1. That is your vertical asymptote. Now what I like to do is go off to the side and do a little picture to help me illustrate what I have and what I'm being asked to find. So I have a coordinate plane here, and I'm going to go ahead and identify the vertical asymptote. Notice I'm not really doing this to scale. Scale is not really relevant here. So this is my vertical asymptote of x equals 1. And then I have my x-intercept at negative 2 comma 0. So what I know here is that there are three potential intervals that could be my domain. The first interval is going to be from negative infinity up to negative 2, but not including negative 2. From negative 2 to 1, not including negative 2 or 1. And then from 1 to infinity. Next, what I need to do is evaluate an x value within each interval to determine if the output is greater than 0. So I'm going to choose x is equal to negative 3, 0, and positive 2. Now the output, when I insert it into x plus 2 over x minus 1, is 0.25, negative 2, and positive 4. So the solution to the inequality is going to be the first interval, negative infinity to negative 2, and the last interval, which is from 1 to infinity. And the solution to the inequality is the domain of the function. So the domain of the function is negative infinity to negative 2 union 1 to infinity. So that's one of the more challenging problems for a logarithmic function where you're being asked to find the domain. All right, guys, good luck.